Yeah. So I had this whole spiel about projected coordinate systems and geographic coordinate systems. And all I'm gonna say is that that the world is not round, and it's not an ellipse, and it's not flat. So there's like multiple ways of basically representing the world. And that's all you should know. And depending on what you're doing, some of them may be more relevant to you than other ones, you know. Some spatial references are good at maintaining areas. Other ones are good at maintaining angles. Other ones are good for navigations. Other ones are good if you're actually collecting data in the North Pole. And there's just a whole bunch of them, and I don't want to talk about it. So that's all you get. And, you know, so we have geometries. We got this concept of features. Then we have basically the idea that for these geospatial data, we have various geospatial formats, right? And they all use different ways of indexing. There's, you know, some formats include how to represent the data. Some other formats are not about that. They're just about representing the data itself. You know, you have like KML tells you how to style it, for example, right? But a shapefile will not tell you how to style things. And you know, there's standards used for navigation, like S57 standards. There's standards used for the web, you know, GeoJSON, whatever. There's all kinds of formats. And they are really indexed differently. And I had like 7 more slides about indexing. And I realized that probably, I don't know if you were interested in that, but we can talk about it at some other point. There's many ways of indexing geodata. And it makes it really interesting because you can do all kinds of queries with them. So, just to give you an example of stuff that you can do with this, this is the documentation of a very popular spatial backend. PostGIS is basically a spatial extension to Postgres, and I heard a whole bunch of people talking about it while we were eating, so I'm just going to show you some of the things you can do with that. We're probably going to have a presentation on that at some other meetup, so I'm not going to get into it too much. But just to give you an idea, so they contain, they basically have a way of representing these geometries. And they have a whole bunch of functions that allow you to operate on these geometries, right? So if you want to find out things like, you know, length of line strings, distance closest points between 2 polygons, or buffer them, there is pretty much a function for most things that you may need, right? There's something for rotating things. There are things for Boolean operators for finding, what is this one? Centroids. You know, you want to find what's the centroid of a collection of geometries. You want to find out things like, you know, you want to buffer things. It's a pretty typical one. So you have a point, you buffer it. It's an actual area, right? You have a line string, you want to buffer it. And it's, you know, a polygon, things like that. If you want to interpolate, you know, find interpolation between points. You want to find if a point is inside a polygon, if it's touching it, blah, 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 blah. You can do all kinds of things. And that's all I'm going to say about that. Let's see what we have here. So what kind of questions can I ask with these spatial backends, right? I can answer things like, you know, give me, like, what parcels are within 1 kilometer of this fire? Right? I want to know that. That's probably a good question to know. You know,
you mean like a gas fire?
It could be any kind of fire. Yeah. So you know, you do a little query and you pass in the point, and you say, give me the phone number of the person, and boom, you know, within the distance of the bottom, 1 kilometer, boom, you get the answer to that. Right? You want to know how much you're tracking some buses, and you want to know how much they travel until today. You know, it's like, oh, tiny little queries. You tell it, hey, give me a, you know, get the length of the geometries and sum them all up, and, you know, from that day till today, right? For this particular one. And then you get that question answered really easily, right? There's a whole bunch of spatial backends. These are just 3 of them. There's more of them. Oracle Spatial SQL Server, starting from 2008, they support spatial types. There's Informix, DB2, you can spatially enable a whole bunch of them. MySQL doesn't have it. We can talk about that. Sybase, has that something? Yeah, there you go. Sybase.
Couch is spatial.
Couch has spatial. Yeah, I don't know. So maybe you should do a presentation on spatial, on Couch. Are you willing to do that? Okay. So we got that out of the way. That's it. We all understand spatial references. We all understand geometries. Now we can actually start getting into the more interesting conversations. So, number one question asked was actually, what was available as open source? And the answer to that was like, wow, what was available as open source for what? Because it's a big question. So I'm not going to attempt to answer all of it. I'm just going to give a little snippet of it. So like if you were doing web mapping stuff, you want to create your own tiles, or you want to have some JavaScript libraries that are that allow you to have that sleepy map feeling, Google Maps, Yahoo Maps style, Bing Maps style. You want to show your satellite imagery, you want to find contours, whatever, all on the web. There's a whole collection of projects to do stuff like that. Map server knows how to create tiles, open layers. This is the JavaScript library that knows how to interact with map layers, that's generating these tiles and other stuff. And we can have an entire conversation at some point about all these other projects, not a problem. Or you can ask your peers, because there's a lot of people here that have been working with open source stuff. Desktop applications, if you want to be able to load the imagery, start analyzing it, editing, running geoprocessing sort of functions, finding line of sight problems. There's all kinds of desktop applications to do that, like these, right? If you know Grass, for example, it's been around forever, and the interface shows the fact that it's been around forever, because it really sucks. But it's really powerful. It's really, really powerful, and if you can figure out how to use them, more power to you. But I would probably take any of the other desktop applications that grab Grass components as plugins and basically present it in a much nicer way. Yeah. Being a developer, I actually like this better, just because I develop different components, right? And I'm not so much interested in the end user tools. I'm mostly interested in the libraries that I have access to. So if you know about projections, you all know about projections right now, but you don't want to actually deal with it, figuring out all the math to switch, coordinates from one projection to the other projection. You want something that takes care of that, or you want something that tells you just want the component that takes two geometries and tells you whether they intersect, or whether they're on top of each other or contain or whatever. You may want that. Or if you actually work with a whole bunch of data types, let's say that there's 50 geospatial formats, there's way more than that. But you don't want to create a parser for every single one of them. Like, it sucks. You don't want to do that. So what you do is you got to use a data abstraction library. And there are geospatial data abstraction libraries that help you, implement it once, and then whenever a new format comes out, you just, people out there are actually implementing little plugins, plugs into the geospatial data abstraction library that you have, and there you go. All of a sudden, your tool already supports this other new format. So that's this one. It's basically GDAL is a very popular data abstraction library. If you're not looking at any of the other tools, as far as you look at this one, you're actually doing yourself some good. It's a good one. It's simple. The API is really, really simple. The implementation is really, really simple, and it works. Then there's, it's an example of some geometry libraries over there, and another data abstraction library, this stuff that handles projections. There are a lot of open source projects, they don't re-implement the same thing over and over and over. They'll just grab like one of these. And they all have different licenses. These are BSD, really liberal. The other one's LGPL, depends on what you're doing. So so, this is basically a tiny little overview of what's available out there that answers that question. There's a whole bunch of more stuff. A lot of the bigger companies, they're also open sourcing their things. Google open sources a whole bunch of stuff for App Engine and GeoHash implementation, like all these other things that find their way to all these other projects. And well, it's kind of okay. So okay, yeah, it's okay. So there's things like a Simple Geo, right? Like they're open sourcing all their stuff. So yeah, a lot of companies there. So I'm kind of tired of talking. So why don't we actually do some demos of different things? Looking at the time, we may actually have time to show more than what I thought, which should be good. Originally, I thought I was just going to have to pick 3 of these. I may still do that. I'm not gonna show number 1 because I'm assuming you are doing something in regards to that, right? You got it covered. Yeah, I'm not showing number 1. So I'm just curious as to what are people interested in seeing. I don't know if we're gonna have time for all of them, but I can show you these 3.
Augmented reality.
Yeah, so my vote, you have 2 votes. Everybody gets 2 votes. My 2 votes go for 5 and 6. I'll tell you that straight out. Gangster style.
I think you're biasing there.
I am biased. I am totally biased because I've seen the other stuff a lot. But it's interesting for some people. So yeah, how many of you know what OpenStreetMap is? Okay, so you all know what OpenStreetMap is. Okay, so maybe I shouldn't even show that. Are you, any of you interested in seeing a demo of OpenStreetMap? You are. Okay, 1 vote. How about, yes, how many of you know what ESRI is? Okay. That's a lot of people. Okay. How many of you have seen any ESRI tools? Okay. Are you interested in seeing something else that they do? Oh, look at that. 1, 2. Yeah, maybe no. Okay. How about some sample creating your own tiles and displaying them on. Oh, okay. How about 5? Augmented reality, enterprise geodata. Okay, you should raise your hand. How about number 6? Machine learning. Okay, all right. So let me set some of these.
4, 5, and 6.
So it looks like it's 4, 5, and 6. Yeah. Okay. Let's see. Let's start with number 4, and I'm gonna try to do it sort of quick. It's gonna be basically, it's just a 3-stack, a classic OpenGeo stack. A lot of us have seen that over and over and over and over, but it's kind of nice, I guess. There's PostGIS backend, GeoServer doing generating the tiles, and GeoWebCache on the side to be able to show a whole bunch of data, and an open layers front end that gives all the JavaScript stuff. Let's see, what do we have here? I'm gonna sit for that. How many of you have actually seen that combination of things? Oh, not that many. Okay. How many of you are actually tired of seeing that thing over and over and over? Looking at you. Okay, so this is actually a demo that Paul Ramsey did a while back, and he's just been showing, where is it now? Oh, look at that, tiles are out. All right, so what do we have here? So we have basically this thing here is you see it? Okay. JavaScript library that you can use to combine a whole bunch of different tiles from different sources. In this case, this thing is called Open Layers. It provides you the same sleepy map filling. You can zoom out, zoom in. You can sort of like move around. And what we're doing here is basically we have the standard Google Maps